Welcome to the video lecture. Myself, I am Krishnamurthy from the Department of Computer Science and Engineering. Today we are going to discuss about Introduction to Programming. This subject is for the first semester students. So agenda for the today class is we are going to discuss about algorithms and then flowchart. In algorithm we are going to see definition of algorithm and then need for the algorithm, what are the characteristics of the algorithm, then example of an algorithm, followed by definition of flowchart, what are the various symbols used in the flowchart, then followed by we have examples of flowchart. At the end of this video lecture we have the quiz questions. Students have to answer those questions in a Google form attached with this video. First, introduction. What is algorithm? So what is algorithm means whenever we are trying to do any process, any work, solving any problem, we need to have some steps, one by one steps. If you execute, if you follow those steps, we can able to solve any problems. For example, if you want to prepare or if you want to cook any new dishes, we can't able to do cooking in a nice manner, in a perfect way. So what is that we need? We need to follow certain steps. What we have to do first, what we have to do second, all those steps if you follow, we can able to do a nice dish. So whenever we are purchasing any computers, any laptops, any mobile, what we will do, we will follow the manual. In the manual they given the instruction, what procedures we have to follow. If we follow those instructions, we have a better lifetime, we have better understanding of the products. In the same way, whenever we are solving any problems, for solving, getting a solution to any problem, we need to have certain steps. If we follow those steps, we can able to achieve a task easily. We can see one more example. If you want to prepare a coffee, what are the steps we need to follow? So for example, the first thing is we have to take milk and then water, mix it and pour into the kettle. So next one, we have to plug the electronic kettle and then we have to wait for the water and mix water and then milk mixture into a certain stage. Once the water is boiling, we have to wait. Once it is boiled, we have to take a cup. In that cup we need to add instant powder and then sugar. If it is ready, once the water and then mixed content boiled, we can pour this into the cup, we can have a nice coffee. So if we follow this set of procedures, we can have a nice cup of coffee. So the same way, whenever you are trying to solve any problems, we need to follow certain steps. Those steps, the step-by-step procedures, we are calling as an algorithm. So why we need algorithm? Why can't we go directly? Means if we are following the step-by-step procedures before going to the actual problem solving, if we have some plan in hand, we can able to solve any problems effectively and then efficiently. We can able to save time and also we can get the answers in a more accurate way. If you follow a step-by-step process without any confusions, without having any ambiguity, we can able to solve it in a easier way and then we can able to solve it in a faster manner. So whenever we are going for any fields like mathematics, engineering, finance, we have some complicated process. If you don't have plan, if you directly go and execute, there may be a confusion, there may be no result possible. So if you follow a set of instructions, certain steps, we can able to get a solution in a feasible way. So for example, if you want to do any optimization possibles, any optimization works, we need to get solutions. Whenever we need any optimization, we can use the algorithm. If you use the algorithm, we can able to get solutions in a quicker time. We can able to save time also. So what are the characteristics of a problem? What are the characteristics of a problem? Before going to the characteristics of problem, in algorithm, not only for a sequence, in algorithm we can able to solve any problem which involves a selection. There are multiple choices, either I have to solve this way or I have to go that way. If you have any selections, any repeated works, iterations, we can able to use algorithms. So if you take any algorithm, algorithms are not dependent upon any programming language. It is a language independent. We are not following any particular language. It is given as a platform independent, language independent. We can use any algorithm, we can convert into any programming language. So what are the characteristics of a algorithm? If you take algorithm, if you any algorithm has these 6 characteristics, we can say that algorithm is a good algorithm. So any algorithm, we need to have a well defined inputs. We need to have clear and then unambiguous inputs. Well defined input should be specified. What is the output? At least one output for each and every algorithm must be defined. Whenever we are giving any algorithm, it have to give some solution, finite number of steps, no any repeated statements, no any unambiguous things, no any repeated statements. That is what we call finite. After executing n number of steps, we must get some answer. So whenever we are writing some algorithm, there should be some solution possible. Without giving any solution, an algorithm should not exist. Algorithm should not end. So whenever an algorithm is written, it is, as earlier said, it is language independent. We are not writing any algorithm for any particular language based, C or C++ or Java. We should not write any algorithm based on any particular language. What are the advantages and disadvantages? Why we are going for algorithm? Why can't we go without algorithm? Means it is easy to understand. Before going to any particular programming language, if you have algorithm, it is easy to decide how many variables required, what is the data structure we have to use, how many times we have to repeat certain steps. Everything can be easily understood. It is a step by step representation. So if you are converting everything algorithms into equal programming language, you can able to complete any programs. So if you break down a problem into n number of steps, n number of modules, it is easy to convert into a programming language. In algorithm we are doing, algorithm divides each and every problem into small pieces and we are giving it as a steps. So it is easy to convert any algorithm into programming language. Is there any disadvantages? Yes. What are the disadvantages? This algorithm is for normal. Okay, if there is a more repetitions, if there is a more complex logic, then it is difficult to understand from the algorithm what algorithm is trying to convey. When you are writing algorithm, you have to break into a small pieces. If you write like a normal paragraphs, it is difficult to understand. That is a disadvantages. If you have any big problems, we can divide into a smaller pieces and we can go for writing algorithm. That algorithm can be converted into any programming. Next we will see an example for algorithm. So first we can take algorithm for finding average of 3 numbers. So if you want to find average of 3 numbers, what are the steps required to solve? So first thing, we have to get 3 values because we need to find average of 3 numbers. First let us assume n1, n2 and then n3. So these 3 values we have to receive input from the user. Once we have the input from the user, we can add n1 plus n2 plus n3 and store the result in sum. If you want average, what is the total number? 3. So what is the sum? We can divide it by the 3 so that we will get the final answer average. That average we can print to the user. So this is the step by step process. If you follow this procedure, we can able to take average of 3 numbers. So next one we can go for another example, algorithm to find largest among 3 numbers. The earlier algorithm we have seen, that is the sequence, without any selections, without any repetitions, we have written the instruction that is from 1 to n steps. Here there is an example, this is example for selection. Maybe we have to do particular section, maybe particular steps we have to have choices. For example, biggest of 3 numbers, first we have to declare what is the necessary variables. We have to compare 3 variable and find out the largest. So I am using a variable A, variable B and then variable C. So after that we can get the values. After that we can check a variable, first A and B, first 2 variable we are comparing. If the first variable A is greater than B, the condition satisfies, then we can go to the next one. First we are comparing the variable a and b. If the variable a or b is maximum, if the condition a is true, condition true means we can go inside and we can check whether the maximum a is greater than c. If the a is maximum, then we can display or we can give the result as a is the largest. If suppose the condition fails, a is not bigger than c, that means c is the biggest, so we can display c is the largest value. Suppose the condition a greater than b fails, then we can go alternate. Whether the condition fails means a not greater than b, that means b is the greatest, so we can check b is greater than c. If the condition true, we can display b is the largest, or else we can display c is the largest. Here either this one or another one, so that is why it is called as selection. Either this part will be executed or this one will be selected. If the condition fails, either it will check here or it will check the another part. That is why it is called as selection. So there is a third construct that is called as iteration. So in the iteration, a particular step will be executed based on the condition n number of times. So here example, we can find factorial of a number. So in a factorial of a number program, first we have to read input, for which value we have to find the factorial. Here n is the variable, for the variable n we need to find a factorial. So first we are getting the value of n, after that we are initializing. Initially the value of factorial is 1, because factorial of 1 is answer 1, so we are declaring the value 1, and iterating looping statement we are using a variable I that starts from 1. So in factorial what we are going to do, we are going to repeat this step n number of times. What we are going to do, from the value I equal to 1 till the value, suppose we are specifying 5 or 6, this statement step 5 will be executed n number of times. For example, if you take the value 5, it will execute 5 times. So I equal to 1 till I equal to n value, the values factorial equal to factorial into I will be executed 5 times. Once the I value is equal to n, the step 5 will be over, it will come to the step 6, you can print the factorial value. So this is the iterative. So algorithms we can write for sequence statements, selection statements, as well as the iterative statements. So this is the example for algorithm. So up to now we discussed about algorithm, what is the need for algorithm, what is the characteristics of the algorithm, and we discussed about advantages, disadvantages. Finally we discussed about example, 3 examples, one for sequence, one for selection, one for the iterative. Next we will move to the second part of the class, that is a flowchart. So in algorithm we given everything a textual representation, that is a text, we given normal English words. So if you take the algorithm, it may be sometimes difficult to understand with the textual information. It is giving less attraction compared to any pictures. So we can move to the picture representation of the algorithm, that is called a flowchart. A flowchart is a graphical representation or a pictorial representation of an algorithm. In flowchart it is a picture. This picture we can able to see what is the input we are doing, what is the computations we are doing, what are the processing we are doing, what is the output. Everything can be displayed in a picture as a flow of information. That is why it is called flowchart. So here what is the advantage, why we have to move from one algorithm into a flowchart? Because that is the we are giving textual information, whereas here we have images, pictures. First thing is, if you see any image, any representation as a images, as a pictures, it is easy to understand when you are seeing a picture what is the flow, from which part to which part the information flows. Everything can be given in the picture in a clear manner compared to writing as a paragraphs. Second one, it is easy to represent all representations, all the flow, everything represented, sequence of information is given in the form of pictures. So it is easy to follow. We can able to get the clear idea about the logic of the problem. So if you go basic symbols, what are the different symbols used in the flowchart? We have many symbols. Here there are some few most importantly used symbols. First one, we are using a vowel symbol. The vowel symbol we are using for indicating start and stop of a flowchart. Whenever we are starting and whenever we are ending a flowchart, we have to represent that with a vowel symbol. Then whenever we want to get any inputs or we want to display any outputs, we have to use the symbol called parallelogram. So getting input from the user, or after doing all calculation, if you want to print any answers, we can use parallelogram symbol. After getting inputs, we need to do any calculation, any processing. So those things can be represented in the symbol called rectangle. So rectangle symbol is used for representing any calculations or processings. Next we have the symbol called a diamond. That is an important one. Whenever we are having some decisions, selection, either this way or this way, biggest of number, a greater than b. If it is a greater than b or a less than b, we have two choices. So using those situation, if you want to represent, we can use a diamond symbol. Then there is a circle that is used for representing any connectors. There are two flowcharts, or if there is no space, we are going to the next page, or we are connecting another flowchart here, we can use circle to use for connecting flowcharts. Then we have symbols, double side rectangle. If we have any subroutines in a program, in C programming language, C++, we have functions that is called subroutines. If any subroutines we are written in our program, if you want to mention, we can use this double sided rectangle. If we have hexagons, we can do any looping statement, initialization, condition checking, or increment decrement. Those operations we want to represent in our program, in our logic, then we can use the hexagon programs. So these are the basic symbols which we are using in a flowchart. So we can see the examples. The first one, example flowchart for average of two numbers. So what we have to do, first we are starting, so we are using the oval symbol for representing the starting of the flowchart. After that we need to get the numbers. What is the numbers? We are reading a value, b value, and then c value. Get the three values. So that is what we are using parallelogram. Parallelogram represents either input or output. Here we are getting the input, so we are using a parallelogram mentioning read a value, b value, and c value. After that we need to calculate the sum. So it is a calculation or processing, so we have to use rectangle. So sum equal to a plus b plus c. So a, b, c values are added and the result will be stored in the variable called sum. So after this we need to find the average. So the sum value divided by total number of variables. Here there are three variables. We can give 3. So value will be calculated. That is the average will be stored in the variable called average. So after that we have to print output to the user. For input or output we have to use parallelogram. Here we have a parallelogram symbol. The parallelogram symbol we are printing sum as well as average. Once all our process over, then we can use the end for denoting the end of the flowchart. We got to use vowel symbol. So this is the example for finding average of three numbers. Next, it is a sequence operation. Next we can see an example for selection. So suppose we need flowchart for printing area of circle. So the same indicating end of the chart and then starting of the chart with the vowel symbol, start as well as end. Next we need to get the input, radius we are getting. After that we have to process pi or square. So the operation will be done. We are represented in the rectangle symbol. The result will be stored in the variable area. Using the parallelogram symbol we are getting input, we have to display the output. So display the area. So then we can stop the process. It is an example for finding the area of a circle. The next one is factorial of a number. So factorial of a number we have to use iterations, that is repeating n number of steps. What is the equivalent flowchart for that? We need the variables. First we have to declare. So what are the variables we need? N variable for getting the number, and then for storing the result we need a variable factorial. For iterating n number of times, starting value we have to mention. For that we will use the variable I. So first we are checking whether I value equal to n, I value less than n. Till the I value is less than n, for example 5, I value already we declared 1. So it will iterate n number of times, I equal to 1, I equal to 2, I equal to 3, I equal to 4, till the value becomes 5, I less than or equal to 5. Till it is equal to 5, we will repeat, that is 5 times it will be repeated. What are the repeated statements? Factorial equal to factorial into I. So it will continuously do. After that it will increase the value of I. First time it is 1, then 2, then 3, then 4, then 5. So 5 times these two statements will be repeated again and again. First initially it is value is 1, I value 1, factorial 1. So 1, 1 into 2 it will multiply 2. So 2 into 3 it will multiply. So again 6 into 4 it will multiply. Then 24 into 5 it will display. So it will calculate everything and it will have the value factorial. Result value will be in the variable factorial. At last we can print what is the factorial. Suppose if you are giving the input 5, then it will execute 5 times and it will have the result 120. It will be printed. So for using the outputs, we are using the parallelogram, print factorial. Then we can end the factorial. So after this end of the video's lecture, we have quiz question already I said. So the first quiz question is, first one, what is algorithm? What is the algorithm? We have 4 choices. First one, an algorithm is a programming language. Whether it is correct, or it is a pattern and trends used to solve a problem. Whether an algorithm is a pattern or a trend to solve a problem, or it is a step-by-step instruction to solve a problem. Or otherwise, algorithm refers to pictorial representation. Out of these 4 options, which is the correct, you can try to give in the Google form. The second question, in a flow chart, an input or output instruction is represented by. In a flow chart, input-output operations are represented by which symbol? Either it is a rectangle or a circle or a parallelogram, or we are using rhombus. What is the symbol we are using for representing input and output? You have to mention the answer. The third quiz question is, what is the symbol we are using for decision making in a flowchart? Whether it is a diamond or a rectangle or a ellipse or a parallelogram. Which symbol we are using for representing decision makings? Fourth question, what is the following refers to pictorial representation of algorithm? Pictorial representation of algorithm is called either a flowchart or a coding or a program or algorithm. What is the right answer? You can mention. The fifth one is, what is the use of the algorithm? So algorithm is used for plan out the solution to a problem, or a language. Algorithm is a language that has specific syntax, or it is used for testing a solution to a problem, or the last one, it is a platform to program a solution. What is the answer out of this 5? You can give it in the Google form. So you have to submit the answers for each and every questions out of this 5. All 5 you have to answer and submit in the Google form. Thank you.